Because of YouTube, I've been restricted to stay here, so the voice is clear that side. So if you see me wandering around, please tell me to go back. Right? So yeah, the topic is avoid making the right mistake. Although through the slides we would understand what the actual topic is. I don't want to take a lot of time and then explain what it is. But yes, there's some mistakes that we do when we are taking decisions, when we are working on our intuitions and those kind of things. From our past historical learnings, we try to do in the events we try to behave in a way, intuitions. So those topics we are going to talk about today. Let's understand a few things first. I like this saying quite a lot. So if you torture the data long enough, it will confess to anything. And trust me, the same data set, the same exactly same data set, in a meeting you present in a very sad way, in a bad way, in a wrong way, and people would say, "Oh, our sales are going down, our marketing is not working, and nothing is working. We should close down our business." And the same data set you can present in a meeting, the same data set, and everyone would come out and say, "Yes, we are doing very good. We should increase the workforce. We should have more branches. We should have more products. We should have more of those things." See, so it differs the way you present your data sets. It differs how you can present your data set. So there are multiple ways of doing that. This, again, a personal favorite of mine, which is connected to the topic also, which says on the left hand side, if you see, it says confidence, and at the bottom it says knowledge. So these are the two charts that we are trying to create here. So the first one, if your knowledge is less and your confidence is less, you are in uninformed or paralysis stage. You don't know what to do, you don't have any information. If you have knowledge but your confidence is low, then you're in doubt and hesitation. So you're always in doubt, should I do this? Should I not do this? You just have the knowledge. Overthinking, yes, overthinking. And then on the left hand side, if your confidence is high and your knowledge is less, you're misinformed and you'll be doing lots of mistakes. And then the best coordinate, of course, is your knowledge is high, your confidence is high, and that's mastery, which is smart actions. You could do smart actions. So that's the quadrant we want to be on the right top. But most of the time, we are in quadrant which is in red, misinformed and mistakes. But through these mistakes, we learn a lot. We make mistakes, we learn a lot, we redo things, and we understand things, and we perform better the next time. So the knowledge increases as many experiments as we do. So these go side by side. So we have to do experiments to increase our knowledge, to increase our confidence. Confidence. I'm sure you must have seen this quite a lot. Let me ask the question. So this plane went to a fight. This plane went to a fight, and then it came back from that fight. Now they saw bullet holes all over the body of the plane, right? So there were bullet holes on the wing, there were bullet holes on the tail, there were bullet holes everywhere. Now, if you are the person and you want to make this plane more stronger, which place would you fit these armors? You see, you have these armors on the bottom. On the right hand side, you have these armors. If you're given this task, if you're given the task to make it stronger, where would you put the armor? Just anyone. Wings. Excellent. Excellent. Sorry. All that? Over the engine.
Same thing over the engine.
Over the engine. Why over the engine?
Because preparing the engine will take a lot more time.
No. We can see the bullet holes. We can see the bullet holes. So the bullet holes are here. The bullet holes are here. So there's no bullet hole on the body or on the engine. So most of the hits are taken here, and here. Yes.
Because the most security damage airplanes will fall, they will not return back.
So what we are looking at, this is the wrong data set we are looking at. This is the wrong data set we are looking at. If you want to make our planes stronger, more tough, then we have to look at the planes which did not make back, which did not come back. So this is the wrong data set that we are looking at. We should be looking at the planes which fall down, which did not survive, which did not come back, and hence try to make those. So what those would be? Those would be almost not exactly, but almost opposite of where the planes came back. So this is a plane can take hits on these places and still can come back. So yeah, when we are doing data analysis, when we are working on data, when we are working on modeling, when we are doing those kind of things, the selection of the data set, what we are trying to use, is becomes very important to get the best results. Sometimes, so without looking at the data, without looking at the information, without looking at a lot of things, we can pull in some data set, start making the model out of it. At the end of the day, the model is performing excellent, test excellent, train excellent, but in the real scenarios, rain conditions, it does not perform very good, because then that is a different data set, that is a different altogether things if you have not selected the right data set. So yeah, that is the information, that is the knowledge, that's the creativity. So you have to be the creative part. What do you see here? What do you see here?
Some place.
What do you see here? Yeah,
Some trees.
trees.
Trees with grasses and
Exactly right. You at the end, but look now. But look now, right? So it was already there. See, the bear was already there. It's here. It is here. Sorry, I have to change myself to this to not to work. So yes, so bear was already there, but we were not able to see that bear. And the reason is, so these
no,
problems
no,
have.
our vision was wrong. That's why I was seeing the tree because this
Yes.
data is more data.
Yes.
And here is small data.
Yes.
So that's why they are measuring the
Exactly. So sometimes I don't want to refer this to an outlier kind of a situation, but instead, let me give you a different example. Let's say you are working on a data set and you have bimodal data set, for example, two peaks data set you have, and then you're working on it. So if you look at the actual data set, you might find some divisions, some dimensions, some mod, some data there which can divide that. So, for example, you are taking heights, average height, correct? So you found one average height is 525, 5.25 feet, and one average height is 5.75 feet, right? You found these two and you did not have any view on the data set. You start working on it, but later on with the investigation you found that we have male and female in our data set. So if you take females out, it explains the first one. If you take the males out, it explains the second one. So just start working on the data set without understanding what data set it has, what divisions it has, what factors it has. Sometimes leads us to wrong decisions. Wrong decisions. All right, this is a fun activity. Pick one out of these two. So this is a big group from you guys, you and you, madam. On the right hand side, you pick days. All right, so you people are picking days, and you people from here onward, you're picking up months. Understand? Easy. So your days and your months. I'll put the question now. In your scale that you have, estimate how long it takes for a person to learn following skills: standard deviation, kurtosis, and skewness. Just come up with one number. Do not overthink. Just the first number that comes to your mind. Just pick that. Wait. I'll ask. So days and month. All right. Can you tell me the days?
5 days.
You
2 days.
2 days. You 3 days. You
2 days.
and you.
One month.
More month you.
Half month.
Half month you. 3 months you. 2 months. Now you see the difference. The average number of days for you guys were 4 or 5, right? And the average number of months for them was 1 month, 3 months, 2 months, 15 days, 1 month, right? See, it was the same question, and you knew the answer. You knew that those people will be thinking in months, and you would be thinking in days, right? But still, we got the different answers. The average here is 5 or 10. The average there is 1.5 month, whatever. Do you see?
Question is wrong. It's good.
No, it's not the question, it's how you pose the question. It's how you ask the question. In a meeting, you have the same numbers, same digits, same everything. So you're asking, how long can you take, how many months you need to deliver this project? I'll take 3 months to deliver this project. How long would you take to deliver this? How many days you take to deliver this? I'll finish it in 15 days, right? So it's the way you ask questions, you're getting the way you ask questions, you're getting the results out of it. And we see and we that when we saw that practically, that there was a huge difference, same question, huge difference in that. So there is a Cobra effect and perverse incentive, which is when an incentive produces an opposite result intended, also known as perverse incentive. Sometimes the result that we intend, the results that we want to take out, get, is different from what we get at the end of the day. I'll explain this. Listen to this. I'm just taking the name because I read it somewhere. So in India, there was lots of cobras and lots of people dying because of cobra bites. So they said, if you bring in cobra head, we'll give you, let's say, 100 rupees. Correct. So they thought that everyone would kill a cobra and bring us the head, and we'll pay them 100 dirham, 100 rupees, and end of the day, we'll get rid of cobras. You know what happened? People started people started breeding cobras. People started breeding cobras, and everyone at a certain time age, they'll kill the cobra, bring the head, take the 100 rupees, go back very happy. Oh, the government saw this is not working. No, this is wrong. And they said, we'll not pay you 100 rupees. Now what happened? They said, oh, these cobras are useless for us. Now let's release them in the wild. Now, before, if there were 1,000 cobras, now there are 10,000 cobras in the wild. Correct? So sometimes the way you present things, sometimes the way you present questions on things changes lots of other behaviors around it. Again, a very fun game. Yes, thanks to. Again, a very fun game. The thing that I asked you guys is not to overthink. Do not overthink. Just be in your normal state and answer these questions. Obviously, you're too many. I might not be able to ask everyone, but can anyone tell me number series? What would be? Can you find a sequence of these series? So instead, sequence. Give me the next three numbers. All right, 16, 32, 64. Logically, you're right. Sorry, numbers you're right, but what is the logic? The logic is wrong, but your numbers are right. Your logic is wrong. Sorry? Raised to power, raised to power, raised to power. So numbers might be correct, but your logic is wrong.
Current number we are multiple what was the current number?
Exactly. So I'm telling you, your numbers are right, but your logic is wrong. From that side, sorry, powers of two, which your numbers might be right, but your logic is wrong. Why? Okay. Why did you not say 2, 4, 8, 10, 11? Why would we? Why just to check the logic? You could have been wrong also, right? So why were we trying to only get the right numbers? Why did we not try to get the wrong numbers? Yes.
We were basing it off of what we knew.
Yes. Now 2, 4, 8, 9, 10. I would have said your numbers are correct. What is your logic? You would have said no logic, all right? Then you would have said 2, 4, 8, minus 1, minus 2, minus 3. I would have said your numbers are wrong and your logic is wrong. But if you would have said 2, 4, 8, 9, 10, I would have said your numbers are right. What is your logic? And the logic was the next number should be bigger than the first number. Correct? So you see overthinking. Somebody before said overthinking at a different slide, So this is where we go and we start investigating deep inside, start going deeper into the topic. And if you remember, I said do not overthink. Don't use your mathematical brain or raised to power exponentials or those kind of numbers. Sometimes the problems are very, very, very easy. Sometimes the problems are so easy that you don't even look at that. You don't even feel that. You don't even see that. And the reason why is we are scared to make mistakes. We always want to be right, and we can never be right. We should never be right. I mean, never be right does not mean that you should always do wrong things. But I'm saying is, yes, you should not be scared of making mistakes, of doing things, because you learn from that. If you go back to the first quadrant now, everything is there. Now with this knowledge and this confidence, you're moving to a point to certain directions, right? The mistakes, what are mistakes basically? If if there was no mistake, I think half of the inventions that we have today, we would have not made those inventions. At least half, if not all, a lot of them, even if not half, let's say quarter of them, we made them through mistakes. But what is the problem with the mistake? What comes with the mistake
How many are?
is the judgments that we are scared of. Is the judgment we are scared of. One of the questions that I normally always ask, and I tell you guys, tell everyone is, if somebody says that this is a fan, this is a fan, correct? It tells me two things. It tells me two things. He does not know what is a tube light is, or what a light is, and he does not know what a fan is. Do you understand this point?
Yes.
So there are two things that he does not know. He does not know the light and he does not know the fan. Judgment is what we are always scared of, and we don't do experiments. And you did not do experiments here. You just started using your logical, mathematical mind, which is of course not wrong, which is right also. But yes, sometimes problems are smaller than what you think of them about. There was a point I wanted to mention. I'll come back. Now, this is again a point where correlation alone, you cannot falsely assume who two events, how two events occur together. That one must have caused the other. That one must have caused the other. Can I go to a website for you? So this YouTube would still work. So I would want to go to a website. This is not my side, so some of the examples might not be very appropriate, but let's look at them. So the first one is suicide by hanging and strangulation and suffocation against US spending on science and space technology. You see how good correlated they are? Number of people who drowned by falling into a pool, and films by Nicolas Cage appeared in. So how nicely correlated they are? Per capita cheese consumption, number of people who died by becoming tangled in their bed sheets, how nicely correlated they are. So the point of this is the point of this is we have factors, we have data sets, we have functions around the data sets. A data set is coming from your branches, a data set is coming from other places, whatever data set, right? You might find some correlations in those data sets which might not be exactly. So for example, the number of salespeople in one of the branch and the number of finance people performance with the sales figures of those. So you have to check correlations. Only correlations sometimes does not give you the right picture, as we have seen here. So similarly, averages are not the right way to calculate things. So this water was only 3 feet deep on average, but average is not the right measure. We'll come back to this slide. Now this is again a very interesting topic. Says Will Rogers paradox. This is a Will Rogers paradox, and it says the late New Zealand Prime Minister said that people migrating from a place to place can increase the IQ of both the places, can increase the average IQ of both the places. So to relate it to our life, data life is you have a data set and you have another data set. The average of this data set is, let's say, 50 years old people, and the average of this data set is, let's say, 60 years old people or 30 or whatever. The averages are different. Can you tell me, if I move some data from here to here, the averages of both places would increase mathematically?
Maybe.
Let's look at the scenario. Let's look at this scenario. The average of New Zealand was, let's say, 15. The average of Australia was, let's say, 52. Right? So we have this data points 5, 8, 9, 12, 15, 22, 34, whatever, and the Australia data points. Correct? So the average is 15 there, and the average is 52 here. If I just move these two people, the bottom people from the Australia, from here to here, correct? Now you see what happened? The average was 15, now the average is 21, and the average was 52, and the average now is 57.5. Correct? So sometimes moving a data set from one place to another place might increase the averages of both the places, which intuitively we don't understand these things and until we practically see them. All right, another for exercise. Uh, just number A. So head, tail, head, tail, head, tail, head, tail, head, tail. Number A, what will be the sequence? What will be the X in this value? Just only the first one. What will be the X?
Zero.
Sorry, 3?
Wait. The number.
Yes.
Yeah,
0.
Zero.
Everyone agrees to 0? Somebody, anyone who does not agree to 0?
One also could be.
Right. Now, what about the number B? 0, 0, 0, 0, what will be the?
Can be zero.
Correct. What about the C? Correct, correct. But you see, intuitively, or the first answer was again, you saw the sequence, you picked up the next one, you picked the sequence, you picked the number, and you said it would be such a lot of you said for the A, it would be 0 because 1, 0, 1, 0, 1, 0, 1, 0, 1, 0. So it should be the next one should be 0. Now, the thing with the coin toss is it is not dependent on the historical results, right? So you can toss a coin and it can come as zero. You can toss a coin, it can come as zero. The coin would not think that I came 10 times, so this time I should come as zero. Correct? There is another paradox that is very related to this. Is I'll come to that, but yes. So in a random number, just tell me, if you have enough time, you take 1,000 coins and you start flipping it all day long, and you have 1,000 flips at the end of the day, right? How many streaks of ones of, let's say, seven, and how many streaks of zeros, let's say seven, let's say zero 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 zero, and one 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 seven, or let's say nine. How many streaks of this would you get in your 1,000 flips?
50. The chance is not too large. 0.5 times 0.5.
Depends on the situation. So like, if you toss it in a different way, maybe it depends on like the angle and
0 to n.
speed is.
0 to n.
Yes.
0 to n means if I have 1,000 flips, all the 1,000 could be zero also.
0.5.
Go home today.
No, let's go.
Fire an Excel sheet.
Take a coin and do
No, create random numbers, and they are as close as it can be. Although it is not, Excel is not, the random number is not as close as the reality is, but it is as close as it should be. Just create 1,000 rows or 1,000,000 rows. Very easy, right? Copy paste. Put 0 1 0 1s randomly, and then check how many streaks of ones and zeros you get out of it, and what is the maximum number of streaks you get out of it. And then repeatedly do that experiment, maybe 100 times. And then repeatedly do that experiment 100 times. Random number, the streaks would not change. You know, law of averages? If I toss a coin,
You have two faces, so 0 or 1.
yes,
It's 50-50.
yes, yes. But what I'm saying is 7 straight zeros or 7 straight ones, correct? How many times would you get in 1,000 coin
You
flips?
multiply the possibilities. 0.5 and 0.5 times.
Mathematically, yes, we can solve. Mathematically, we can solve it. But yes, do that. And on Excel, it is very easy to copy paste into the next columns, next columns, next columns, and then check at the bottom what was how many six of sevens the first one got, how many the second one, how many the third one, how many fourth, how many fifth one, and you will see a pattern there. So there is nothing random basically. There is a pattern. How many nines, how many 12s, how many 15s of 0 0 0s and 1 1 1 1 1 1s. Law of averages is so if I toss a coin, one time it comes as head. The first time it comes as head. So I would say the coin 100% of the times comes as head. Correct? Because we have one circle, one result, one event. If you do it twice and again it comes as head, we would say the coin comes at 100% at two events also. If we toss it again and it comes at head again, then we say 3 times and it came as head. The coin always comes as head. Right? When do we start seeing the average results? When do we start seeing the patterns? What is the number of data set that we need to get the accurate averages out of it?
More data.
All right. So law of averages is, let's say, one example is, so initially the So initially the averages moves quite a lot. Initially the averages moves quite a lot, and then slowly, gradually, they become one average number. One of the examples that I was trying to give here is performance. When we are working on performance of human activities, some are very some perform very high, some perform very low, some perform very high, some perform very low. But if you keep on averaging them, if you keep on averaging them over the time, they would come to an average number. One thing more related here, a small research that I did was I asked 1,000 adults to create fake random numbers of coin tosses. So they created 10 or THT, some kind of a thing. So 1,000 numbers or 400 numbers. So they created in their mind head, tail, head, tail, 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 head, tail, head, tail, 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 head, tail. 100% of those people were predictable. The next head or tail was predictable to about like 80-70%. There was no randomness in it. And then I asked 10 years old and younger to do the same, and they created head tail, head tail, head tail, head tail randomly. And at end, after 1,000 results, they were all random. You cannot guess the next head or the next would be tail. So their predictability was 30%, 20%, 40%, and the adults' predictability was 70%, 80%, sometimes even 90%. Because we don't understand random numbers in reality. We do not understand random numbers. If I ask you to create a sequence of a random number and then put some machine learning on top of it, I'll be able to predict what will be your the next number. So what I can do is 1,000 numbers. So I take 900 numbers, I keep 100 numbers separate. I create a model on the 900 numbers, and then try to predict your 100 numbers at the end. At the end, and I'll be able to predict that 90% with 90% accuracy, confidence. 80%. We don't understand random numbers. So yeah, so one of that topic is here. Again, a very fun activity. Just think of a number.
So,
You met him at the end. 12. 10. 10. I'll show you the next. Sorry?
126.
1,000.
Why do? Why? So there was some 1024, there was some. You were, but you didn't. I'm really sorry. I wish I have the. Is it telepathy or what? How do you mind reading? So yeah. So why do we? So these questions and these things again, we can pose these kind of questions to get the results we want from the audience, from the meetings, from whoever stakeholders, from whatever we want to see. A very interesting paradox. Oh, this is smart. Smart. I was probably sleeping when I was last night working on. So smart and rude. Correct? So what they say is the more smart you are, the more rude you are. Okay. So the smarter, the ruder, or the ruder, the smarter. Correct? So it goes in a linear fashion, increases. Correct? And what the Bergson's paradox says is, see, we cannot take 100% of our data set for machine learning modeling, right? 100% of the data set to fit in our machine learning model. First thing is the research sometimes would be impossible. You might not even have that much resources or money or anything. So if you want to check the height of everyone in this world and then trying to make a model out of it, it is impossible. You cannot check the height of everyone or the weight or whatever salaries or whatever. It is impossible. So you have a selection of data set and you work on that selection of data set. You create a model and then you test it on a broader data set, and then on broader data set you have an accuracy of whatever number, 70%, 80% accuracies, and then you run it, test it, tune it, kind of a thing. So you don't have the 100% data set, correct? So look at this. So the data with the white filter, the data with the white filter, this one, and the data set with the white filter, that one. We're not taking that data set. We're just taking the data set that's in the middle.
It's average.
Sorry?
It's average.
Could be a lot of, yes, could be a bit. Now you see, our initial was that the rudeness and the smartness increases, right? But here it is opposite. So yeah, selection of data set. Sometimes the actual data set might not tell you everything, and then you have to take a sample of all the areas of field of domain data set that you have to come to a final conclusions. You cannot just handpick sometimes few things and then be able to make good models out of it. Right? Quickly, so this is another effect in which this is more on the management side and on the business side. So let's say you have two departments, and one department you're just making them very, giving them food and everything and keeping them very happy, and the other department you're not even looking at them and let them work and do whatever uh, uh, worst hours of time and all of those things. So you have two these things. End of the month you see that these people who you're working very closely and giving them food and pizzas and burgers and music and dance and all of those things perform very well, and these people who were miserable are not performing. So what is the reason these were performing and they were not performing? The reason they found out was not the food, was not the music, was not the dance, was not all of those things, and it was the attention that they were getting. So it was the attention which made them work better than the food or anything else. So that's also an effect. Let's say you're driving in Dubai. How many in percentage would you see number plates with at least one even number in it if they all had 5 digits? Don't use mathematics. Keep your mathematics aside. Don't give me formulas. Do this and this and that. It's the first number that comes to your mind. So the question is, if you have 5 digits, 1, 2, 3, 4, 5, how many number plates would have at least one even number in it? So at least one even number in it. At least one even number in it. So sorry, 20%.
He said 20 as a 50.
If 50, you're saying 20. Just shoot a number. Say a number. Say a number, sir.
100%.
100%. 100%. 100%. 100% is not possible. So you have 13579, right?
70%.
Or 11111.
No, it will be 80.
So one minus 1 over 32. 1 minus 1 over 32.
So now give me a percent.
So 1 over 131 over 32.
Which is the number?
Around 97. 97 or 96.
Yeah, you're absolutely. You are right. Very close. You're very close. But it's 96 point something, right? At the first instance, it doesn't even look like that. We started with 20%. We started with 50%. We started with all of those numbers. Remember, I'm not checking. We're not testing the mathematical mind today. We are checking. We are just trying to fine tune our intuitive mind. We just fine tune our experimental mind and all of those things. So it is this number, these many numbers. And I've started a very bad habit. When I drive, whenever there is a car in front of me, I sum those numbers always up. I always sum those numbers up. And now with maybe 3, 4, 5 years of experience, I can just glance and add that up. I don't know if I can use it. Can I go to Guinness Book of World Record with that? No. So how many with the odd number plates? So 96.5 minus 100. So will it be 3.5%? Very good. Please do not use your mathematical mind, please.
It's going to be 96.
Exactly the same, right? It exactly the same. Same number of even numbers, same count of odd numbers, same 5 digits. It's the same. It's the same. I think you said same, right? It just ties back. Remember when I was looking at this, and I thought, and I said, I'm trying to remember something I forgot, and it will come back. It was basically gambler's policy. This one, gambler's policy, which is exactly the same, but applies to more things, right? If you're winning in a casino, you start putting more money because you're winning, and then suddenly you'll lose all of that. That's the gambler's policy, which is sometimes the events are not driven by the historical events.
Believe something because of the statistics, like because of what you think, and it actually is good.
Exactly. Same with the point. This example is very similar to that example. And this is the last slide. Thank you guys. Thank you very much. Sorry. Questions. No, I was mindful of the other person who is coming.
Okay. No, we take your questions in that time.
Sure, go ahead. Yes.
What was the right mistake in your experience or your experience in the data science?
I don't want to tell you. I graduated almost 25, 30 years back. Right? Now you know my age. Well, there's the youngest person there. There's the youngest person. No. There is a kid in the front. As the youngest person, and I'm the oldest person in this place. There was no machine learning at that time. We were working in Fortran and card readers and punch cards and all this kind of thing. So I came to this place by mistakes. Mistakes I did in my life. What was the worst mistake? What was the best mistake? That's a good question. Nobody has asked. Nobody has asked me that. But if I would have made millions of mistakes. Yes.
Wrong question, wrong answer.
I'm really struggling right now to find out my worst mistake or the best mistake must be. But thank you for asking that question. Now I will come up with it.
The topic is about making the right mistake, and the talk is all about like the different mistakes data scientists make.
Yes. I must have done. What do you remember? What do you remember? The events that are solo events, right? The events that are solo events, right? Once in a lifetime events, right? if I've made mistakes millions of times in my life, I've not been able to remember any of those mistakes. So probably that's the reason I'm struggling to answer. Any other question? No other question?
So for someone who's getting into data science, right,
Yes.
who's getting into AI and
Yes.
what is the one thing you recommend them to, to ensure that they don't make that mistake which is wrong?